Let me hit present my screen and I'll get going. All right, share. Okay, you should now be seeing my screen. I'm not going to see any of your faces anymore. I'm sorry, but because I'm going to flip my computer, and I'm sorry you kind of see up my nose. I apologize for that, but it's easier for me to write on this. Hopefully you noticed that I'm not just doing some weird thing in class. I got a new fancy thing to write on. So it's really, really nice. I'm looking forward to next year for those of you who get to have me again and having this in classroom. All right, so I tried to pick out problems where the common theme in the problems was separation of variables. They're not all separation of variables. You'll notice that that's the way free response problems always are. There are some things that they're going to embed all kinds of things, and that's the way this year's is going to be. We've talked about that it's not just going to be 2 or 3 topics. There's going to be like 7 or 8 different topics embedded in one problem. If it's your first day, even though I know it's your second day, don't be overwhelmed by these. The more we do them, the better you're going to get at them. Think of it as part A is just one problem, part B is just one problem, part C it's just they're all kind of started with the same question step. Okay, and you don't need to do one question. All the questions. You don't need to do part A to necessarily do part B or part C a lot of the time. All right. So we're doing 2019 number 4 to begin with. Remember, I can't type out everything. I've tried on the rate problems. I'm typing out a little bit more. It dawned on me. I'm using OneNote. It dawned on me. I hand wrote everything yesterday. I'm like, oh, gee, I could have typed all that. So duh. So I typed it a little bit more today, but not the whole thing. So you probably want the problems in front of you because I just typed kind of notes on it because I'm not allowed to publish College Board stuff online. And if I'm recording, I'm publishing online. So, no. A cylindrical barrel with a diameter of 2 feet collected rainwater. So here's my little barrel right there. And we know that it was, in fact, the diameter is 2 feet. So if the diameter is 2 feet, that means that the radius is equal to 1. Okay, and it's better to have the radius measurement in there than the than anything else because all of your formulas, your circumference and your area formula in terms of radius. The water drains through the valve, not shown at the bottom of the barrel. The rate of change of the height of the water in the barrel with respect to time is modeled by this function. So remember rate of change. So we want to think of that every time we see the word rate, we think of the word derivative. Okay. And the height of the water, and it's the derivative of the height. So, and you'll notice it's in dHdt. So they've already given us that derivative. So yay, we don't have to find it. H is measured feet, T is measured in seconds. They also were nice enough to give us the volume formula. So you don't have to actually come up with your own volume formula. All right. So they want us to find the rate of change of the volume. So remember, rate is derivative. We also want to ask ourselves to see if that word rate is in the right place. We read it as how fast. So find how fast is the change of volume with the water at the barrel with respect to time. So it really is it is in the right spot. Normally, if it's in the back, we move it to the front. So derivative of the change of volume. Okay, so it's the derivative of the change, which means what you're really, really looking for. Oh, actually, no, we're derivative of the volume. So we're looking at this equation here, not this, because this is the height. Okay. They say they want it when the height of the water is 4. So the water is 4, but you don't want to put that in right away. Okay. So I'm going to write down that volume formula. So we've got the volume equals pi r squared h. Now, because this is a cylinder, the diameter and the radius never change. It's not like the cone. You guys remember the cone? We did the cone problem. And then this one, the radius is constantly changing. Okay. So we're just doing this one, the radius is constant. So we can make this simpler rather than having to do an implicit differentiation in a product rule, which we want to avoid if we can. So I could go ahead and put that radius in there because that's a constant. So volume equals, and it's 1 squared is 1. So it's really pi h is the volume of this particular cylinder. Now it wants the rate, which means we have to do the derivative because we haven't done any calculus yet. So dv dt equals pi, and then the derivative of h with respect to time is dh dt. Okay. We know what dHdt is. dHdt is this guy right here. So I need to take that and I need to substitute it in. So pi times -1/10 square root of h. Okay. Now we actually need to evaluate that specifically at when h is 4. And look at this. You had to plug a 4 in. You had dHdt. You had nowhere to put it. So it's obvious that you have to substitute the dHdt in. So pi times -1/10 square root of 4. All right, so you've got pi times -1/10, and then square root of 4 is 2. You really don't need to do that. Stop here. Okay, I'm going to keep simplifying just a little bit, but that's where you really could stop. If I reduce this a little bit, I end up with -pi/5 for my answer on that one. Okay. On an AP test, that would have been, oh, we didn't put the units on it, did we? And it said indicate units of measure. So we have to put the units of measure on there. In this case, the units of measure would be feet cubed per second. So if I was going to score this on the AP test, and this was actually, you were actually getting points on this, they would have given you 1 point right here, which I didn't really do this yesterday, 1 point right there, and then they would have given you 1 point for the answer with the units. So if you didn't have the units, you'd lose the point. Okay. So even if it doesn't say units, if there's units, write units. Okay. When h is 3 feet, is the rate, I missed a word in there. When the height of the water is 3 feet, is the rate of change. So the rate, I didn't put that in there really. So the rate means derivative, rate of change of the height of the water. So they're talking about the derivative of the height. So they're talking about dH/dt. Is that increasing or decreasing? This one's kind of deceiving. They want to know if the dH/dt is increasing or decreasing. So we know we get increasing or decreasing from the derivative, but our original in this case is the derivative. So what we need to do is we need to take the second derivative, or the derivative of the first derivative. Our original function, which I have now lost, so I'm going to write that over here, dH/dt equals -1/10. Instead of square root of h, I'm going to write h to the 1/2 power. So if I'm going to go ahead and take that derivative, okay, and we're going to do this implicitly, okay. So I'm going to take this 1/2 and put it in front, so you get -1/10 times 1/2 h, and then we subtract 1 from the exponent, or subtract 2/2, so -1/2 power. Okay, and then remember when we did implicit differentiation, you also took the derivative of this with respect to time, so dH/dt. You have to put that on there. And again, if you've got questions about what I'm doing, stop me. Okay, so you got -1/20th. This is, I'm going to make that happy by moving him downstairs, so I'm going to do a lot of steps here. dH/dt. Okay, and then I'm going to put this guy that says 1/2 under a square root, so -1/20 square root of h. Now, I know dH/dt, right? So for this, I know that dH/dt was equal to this, or it's up here, it's nicer up here, this. So I'm going to substitute that in. This is one thing they kind of love to do to you. Okay, I'm going to substitute that in this for the dH/dt. So I'm putting in the -1/10 square root of h. And then we haven't actually found it when it is 3 yet, right? No, we need to talk about increasing, decreasing. Okay, so before I even do that, look at what happens here. This h is in the numerator, this h is in the denominator. It's like that. I got -1/20th times -1/10, which is 1/200. We just showed that our second derivative, no matter what we plug into it, is greater than 0 or positive. So that means if we've got a positive derivative, remember it's the derivative of the derivative, so it's still acting like a first derivative. If we've got a positive derivative, that means that this is increasing. Okay. So this is the sentence I would write, and we've got some AB. I know you guys have some sentence frames out there. So when the height is 3, we want to write the words of the problem, which were the rate of change of the height of the water is increasing, and we had to explain it. So because, and then I would write that it was the, what was this, the second derivative. So d squared h over dt squared equals 1 over 200 is greater than 0. I'll give you a minute there, kind of catch up on what you're taking notes on. Okay, I'm going to look at part C now. Okay, so notice this was supposed to be about separation of variables today. We haven't hit any separation of variables, but now it finally comes up. Oh, points wise on B. B was worth 3 points. They gave you a point to do this, to get to this derivative right here. No, which one? Yeah, to get to this derivative right here was 1 point. Oh, I take that back. To get that was 1 point. To get to this was a second point, and then to answer explain this was a point. So that would have been a 3-point section of the problem. I don't know how, at least you can see kind of what where they're giving the points at. We don't know how much the points are going to be this year. And keep in mind, and I know this is kind of shocking, you need to basically get a 40% to get a 3 on the test. A 60% gets you a 5 on the test. So this is totally doable for you guys. Okay, a 40% is an F. Okay, a 60% is a D. So you just got to get 40% of the material right. You're going to be fine. You got to practice though. All right, let's keep going. So at t equals 0, h equals 5, separate the variables. I should probably, at time t equals 0 seconds, the height of the water is 5 feet. So I kind of wrote that there. That is an initial condition. Use separation of variables to find an expression for h in terms of t. Okay, so I'm going to write my function out again. So dh dt equals negative 1/10 square root of h. I know I've got to separate my variables, so to bring this to the right, like you always keep the coefficient on the right side, I go dt. I got to take this to the left, so that means I have to divide by it. And then I'm going to rewrite that. I could rewrite it as h to the 1/2. But before I go to integrate that, I need to bring it upstairs, so I'm going to make the exponent negative. Oh, pen battery, no, please. Oh, good. My pen's dying. I don't know what I'm going to do now. I apparently can't use the pen. I didn't charge it. Give me 1 minute. I'm going to go see if I can find another pen. I'll be right back. Oh, wait, take that back. We have 2 of these things. Maybe there's a pen in this one. Let's see if this one works. Ah, okay, we're fixed. We're good. Okay. All right, good news. We have 2 of these devices in the house. All right, so I still have to have a dh right there. I haven't integrated yet. Minus 1/10 dt. Okay, I'm going to integrate both sides now because I probably got some points right in there for just doing the separation. I'll tell you that at the end. Okay, remember when we integrate, we add 1 to the exponent. So h to the, that would make it, sorry, I added 1/2. So h to the 1/2. We divide by 1/2 or we multiply by the reciprocal, so we multiply by 2, plus c, but we don't ever put plus c on the left. And then we've got negative 1/10 when we integrate dt, we get t plus c sub 1. We like the c sub 1 just in case we have to move the c a couple times or change it a couple times. All right. Really what we need to do is we need to, if the algebra is not too bad, we need to get h by itself because eventually we have to have it in terms of h. Okay, so I am going to take this guy and move him to the other side. I'm going to do that by division. So I've got h to the 1/2, or the, I converted it back to square root of h when I was doing this earlier because it made more sense to me. So square root, ooh, that's the wrong color. Square root of h equals, I'm dividing by 2 or multiplying by 1/2 t plus, and really if I'm dividing that by 2, I'm really turning it into another's constant, so I'm going to call it c sub 1. I don't know why this guy's coming up. All right, or c sub 2. And then I'm going to undo this, and this is where this one is really weird and tricky and kind of icky. in order to undo the square root, I have to square both sides, but I have to square that thing together. So the whole thing gets squared plus c sub 2. This one here is negative 1 over 20t. Okay, so I've got it solved. It's h equals. The problem is that I have to solve for this particular solution. I have to use this initial condition, and I haven't done that yet. They're never going to give it to you if you're not going to use it. So I'm going to put in for h, I'm putting in a 5, and for t, I'm putting in a 0. Okay, the goal here is to solve for c. So we know that this is going to be 0, so 5 equals 0 plus c sub 2 squared. I have to get this to the other side, so to do that, I'm going to take the square root of both sides. Technically, we would have a plus minus square root, but because of where it's at, it's going to stay positive. So c sub 2 is square root of 5. All right, so now I got to take that and I need to put it back into that line right there. So, nope, not that line right there. This line right here. So h equals negative 1 over 20 t plus c sub 2, not c sub 2, what am I doing? Plus the square root of 5 squared. That's your final answer. Let me tell you where the points are from, okay? So the best point on almost the entire exam is right here. You get 1 point for separating those variables. Please, 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 if you're given one of these, write that down, okay? Everybody can do that. You get a point for the antiderivatives, so you got a point right here once we took the integral. Okay. This one wasn't worth as many. Sometimes this is worth like 5 points. It's usually a big problem. You get a point for it's kind of split for getting the C and for substituting in your values there, your initial condition. So that's 1 point combined together. Sometimes that's separate. And then you get 1 point for this final answer. So that one was only worth 4. Typically, it's worth 5 or 6. So that happened to be worth a little bit less. All right. Are there any questions on that first problem that I need to clear up? I'm watching the comments, or you can turn off your microphone and ask. We have a few visitors that are back. We're not done yet. Go away for a little while longer. Okay, I got 2 more problems to do. Okay, all right, here we go. I didn't hear any questions, so here's 2018 number 6. Okay. Okay, so we're going to skip part A, which is the slope field. This year, because of the nature of the test, you can't write that they can't expect you to print that out, and they can't expect you to print it out and then put it and then try to write it. There's not enough time to do that. So you're not going to have to sketch a slope field this year, most likely. So we're not going to worry about it and move on to what is going to be there this year. So we're going to so one thing that's interesting is y is equivalent to f of x. Okay. We want that to be the particular solution to the differential equation with the initial condition. And so they gave us this initial condition. They even said it was an initial condition. They want us to write an equation of a tangent line at x equals 1. Okay, so remember, for equation tangent line, we need 2 things. We need a point and we need a slope. All right. Once we've got that, we're going to use it to approximate f of 0.7. So this is actually this is a nice question. Okay, so you want to be able to get this one done. So I see a point. We have point. It's right here. Okay. I need slope. I don't have the slope, but check it out. I've got a derivative, and I know that the derivative is equal to the slope. Okay. So I'm going to plug my initial condition into the derivative. So dy dx equals 1/3. We've got the x, which is 1, times 0 minus 2. You got 1/3 times -2, or -2/3. Okay. I did something wrong. What happened? Oh, I was supposed to square it. There's a squared on there. I missed the squared. So it's squared, so it's negative. It's not negative, it's positive 4/3. Okay. All right, I'm going to put that into point slope form. Remember, point slope form is y minus y1 equals m times x minus x1. You should all know that. We've got y minus, and you're going to put your y value in, which is 0, equals my slope, which is 4/3. times x minus 1. Typically, if they're just asking equation tangent line, done. Don't put that, don't do anything else with it, okay? But they're asking us to do this approximation. So remember they told us that y equals the equivalent to f of x. So I'm going to switch that y to f of x equals 4/3 x minus 1. Don't distribute. Your life is not going to be very much fun if you distribute, because your arithmetic's way easier if we don't have to deal with that fraction. I'm going to plug in 0.7. So 4/3 times 0.7 minus 1. So 4/3. Now notice, this would typically have been, what happened? Uh-oh. I lost my whole notebook. It went away. I gotta find it. Let's see. OneNote, where did it go? On the plus side, I'm seeing all your happy faces again. OneNote 2016. Okay, let's see. It's coming back. All right, uh-oh. Where did it go? File, open. There it is. My notebook. Let's see if that's it. No, wasn't that one. File. Normally it's just there. That's not it either. I lost it. How did I lose it? Oh, wait, there it is. I see it. It's coming. Okay, it's in a totally different order. This one. That's got to scroll down. So I think I just added on to, nope. Oh, here it is. There it is. I found it. Okay, we're back in business. Okay. All right, here we go. I did nicely saved and everything. That's awesome. Okay, so go back to my nice little draw menu. Oh, the draw menu looks different now. That's not good. All right, something happened weird. Okay, so the nice thing about it being in this spot right here is that that's way easy to subtract, because even though I know you're allowed to use a calculator on everything this year, you want to not have to waste your time on it. So you know that that's negative 0.3. And when we actually multiply that, it's negative 0.4. Again, don't do these. Don't bother. Stop here. Please. I know I keep going because I know some of us are needing that extra, but just stop there. Okay, because you don't want to get it wrong, and you have 25 minutes, and you've got to figure out those 25 minutes kind of on your own, and we'll keep you watching the clock on your own. I don't want you to make a mistake coming here. Stop there once you've got that. I've got it down to numbers. Let me show you where the points are there. Okay, I don't know what I did with my fancy colors. So the points are coming from, let's see, you got to get the equation, a tangent line, the approximation. So you get a point here. And you get a point for this approximation, 1 point there. So that one was 2 points, but still worth the 2 points. Okay, every little bit helps. All right, I'll go back to draw, find a different color. My fancy pens are gone. All right, so find the particular solution. So let me read from the paper. Find the particular solution, y equals f of x, to the given differential equation with the initial condition at f equals 1. Whenever you see this means separate variables. Okay, particular solutions always separate the variables. And this is the stuff we ended with right before we left. Okay, all right. So I did a couple of different ways. Okay, so I did this. You can kind of see it. I don't know if you can see that or not. Probably not. I made a huge mess of it. So I'm going to not, the last one here, when we did this, we went and solved for this variable first before we plugged in the initial condition. When I did that on this one, it was a huge, huge mess of algebra. So you don't have to go all the way to there to substitute in. So I'm going to show this one a little differently. I'm going to show my substitute in earlier on in the problem. Okay. So I got to get my function back in there that we had from the top of the page. So it was dy dx equals 1/3 x times y minus 2 squared. All right, we got to get the y's to the left, keep the x's on the right, and the constant or coefficients on the right. So in order to get this to the other side, I got to divide. So 1 over y minus 2 squared dy equals 1/3 x dx. Just earned a point. Separation of variables, okay? We have to integrate. Now, you got to be careful right here. you have to watch for a U substitution right there, okay? But if I, or not use, yeah, U substitution. If I was going to do U on that, however, I would just get a 1. So there's nothing I need to worry about. Really watch if that coefficient is something different, then you really need the U sub, or if there's a negative in front, then you really have to have the U sub. They're going to sneak that U sub in somewhere. You're going to have to do it somewhere on the free response because they need to test that skill. All right, I'm going to rewrite this. It's y minus 2 to the negative 2. We got to bring it upstairs in order to integrate it. All right, so we're going to do our integration. Add 1. So y minus 2 to the negative 1 power. And then we got to divide by that new exponent. So when we divide by, and we're divide by negative 1, equals, and when I integrate this, I get 1/3 x squared plus c sub 1. All right, I'm going to rearrange this a little bit. I'm going to float the negative in front. I'm going to bring this back downstairs where he's happy. Okay, so instead of taking this and solving for the y, because this is a huge mess. Yeah, what's wrong?
You forgot to divide by the 2 on when you integrated the x.
Thank you.
Okay.
Thank you for catching me. So I didn't get into the slope issue I had yesterday. All right. So this is a huge mess, okay? Messy fractions. We get weird complex fractions over here if I try to solve for y. Let's save that for the end after we have plugged in our numbers. So I'm going to go ahead and I'm going to substitute in my initial condition here, okay? You don't need to write that necessarily. I'm just kind of giving you some notes on what I'm doing. So my initial condition, remember, was x equals 1, y equals 0. So 1 minus 0 minus 2 equals 1. Actually, I could put this together, couldn't I? 1/6 times the x squared, which is going to be our 1, plus c sub 1. I'm going to use this to solve. Okay, I'm going to move my work up here. So we've got negative 1 over negative 2 equals 1/6 plus c sub 1. That's going to go positive. I need this in sixths, so I know 1/2 is 3/6 equals 1/6 plus c sub 1. Okay, I got to take this and move it over. So when I subtract that over, I get 2/6 equals c sub 1, which is the same as 1/3. I'm now going to take that, and I know this is going to be where I'm drawing arrows everywhere. I've got to plug that back into this guy right here. Okay. So I've got negative 1 over y minus 2 equals, I'm going to, instead of the 1 and the 2, I'm going to go ahead and make that the 1/6 x squared plus 1/3. Okay, so let me explain the algebra. I still have to get y by itself. Normally we would say on the free response, done, don't do anything, don't touch it. But this is the one case in these that you actually have to solve for the y, okay? So what I could do, follow order of operations. I could take this guy and multiply him on the other side, and then I could divide by a negative, okay? If I did that, because I have to take this, or actually, and then I could divide by this stuff to get it over to the other side. If I did that, would ultimately, let's actually do it, just so you can see, okay? So I multiplied that over to the other side, so I've got negative 1 equals 1/6 x squared plus 1/3 times y minus 2. Then I could take this guy and move him to the other side by division. So negative 1 divided by 1/6 x squared plus 1/3 equals y minus 2. If I had simply, in this step right here, let me use a different color. Okay, in this step right here, if I had simply just flipped the numerator and the denominator on each side, so I get negative y minus 2 equals 1 over 1/6 x squared plus 1/3. Okay, if I had simply done that, I would have ended up with the same thing. I just need to move the sign over. So if you want to just flip it, you absolutely can. Okay, the only thing I need to do to finish this up is to add the 2 to the other side. So y equals negative 1 over 1/6 x squared plus 1/3 plus 2. Okay. All right. Any questions on that one? That's, oh, I need the points, huh? Let me get the points on there. All right, so this one was a big one. Let's see. This one had 5 points in it. You got 1 point right here to separate the variables. If you don't do that step, you don't get any points at all, so you have to separate the variables. You got 1 point for this antiderivative and 1 point for that antiderivative. You got a point for the constant and then plugging in the initial condition. So that's all a point together. And then you got a point for solving for y. So you got a point for this one right here. All right, we are going to do the famous baby bird problem from 2012. I actually remember the students who did this one. I don't know if any of you remember Lauren Bond. I know she's been a long time ago, but I remember them coming in from her AB test junior year and complaining about this problem. So Maddie drew me a baby bird to put in here. So thank Maddie for the baby bird. It's pretty awesome. So we're reading the baby bird problem. So we've got the rate. Remember when we see that word rate? It is, I don't want that color. The rate is a derivative. So automatically we know we need a derivative somewhere, okay? The rate at which the baby bird gains weight is proportional to the difference between its adult weight and its current weight, okay? At time t, the bird is t equals 0, the bird is first weighed, its weight is 20 grams. So that right there was the initial condition. If b of t is the weight of the bird in grams at time t days after it's first weighed, then they give us this nice little derivative. And this derivative is really referring to the rate the bird gains weight. Yes, baby bird gains weight. Okay. And then again, they state let y equals b of t be the solution to the differential with the initial condition. Again, they gave us that initial condition. Again, they've given it to us twice and now explicitly stated that. So it says, in part A, is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? Okay. So we have to figure that out. Okay. Oh, this thing is not in the right. It's acting stupid. It kind of in our little flub up, it made my picture go in the wrong spot. So what I'm going to do is we're looking at rates. We have the rate. All we have to do is literally plug 40 and plug 70 into this thing right here. So let's do that. So dB dt. Now, to show the reader what you're plugging in, you can draw this notation. You just draw this bar, and you say that I'm going to plug for the B, I am plugging in a 40. It's just notation to tell the grader what you are actually intending on plugging in. So 1/5 times 100 minus 40. Very doable without a calculator. This was a question 5. You wouldn't have had a calculator on it anyways. So 60 equals 12. In this case, yes, you would get credit for this, but you actually need to do a comparison of the numbers, so you really do need to go to that final number. So then we've got dB dt, and we're going to plug in this time a 70. So we've got 1/5, 100 minus 70 equals 1/5. 100 minus 70 is 30. So that is 15. Okay. So no, it's not 15, Mrs. Ballard, who doesn't do arithmetic well, apparently. It is 6. Okay. So we know that the baby bird is gaining weight faster when it weighs 40 grams. So we need to put that into a sentence. Okay. So we would say you got to kind of have a reason. So since dB dt when b equals 40 is greater than dB dt when b equals 70, the bird or the baby bird, remember use the sentence stem or the words of the problem, bird is gaining weight faster when it weighs 40 grams. And honestly, having children, that makes sense. You gain weight a lot more or quicker when you're a baby than we do now. Okay, unless you're apparently in quarantine, maybe then we're gaining weight faster right now. I don't know. So part B. I had at least 2, 3. I saw at least 3 BC kids in the room. My BC kids in the chat right now, tell me what that picture looks like. What equation does that look like? Do we remember? I know Connor knows. Maddie, Cassandra, do you guys know? Type it into the chat so I can see it pop up. I'm watching the chat on Ellie's computer. I'm not seeing anybody in the chat. Are we all still there? Did I lose them? No, they're all still there. Do we have to put capital B on the test? Okay, so Maribel, yes, if it's capitalized, capitalize it. If it's lowercase, keep it lowercase. You want to follow the notation of the test. Okay. Nobody remembers what kind of curve that is? All right, you're disappointing me, right? It's not a tangent thing. Thank you, Connor. It's logistic. Okay. So it doesn't have anything to do with this problem, the name of that curve. Okay. But it's a logistic equation. And right now, you guys, this is actually super, super relevant to what we're doing right now. What we're experiencing right now, the coronavirus, it's actually following this curve. You're talking about the flattening of that curve. That's what they're talking about, as they're trying to wait for this to flatten out. I know I pointed out to the BC kids, AB, we'll get into that next year when I get to see you again, those of you that are juniors, which I'm super excited about. We've got an example. Mr. Lapis has already been putting it into Desmos every day. So we can actually have some data on it. So this is actually, it's being very explicit. It says, hey, find the second derivative and then explain why we can't use that graph to resemble it. All right, so I'm going to take that original equation that I had, which was dB dt equals, I lost my work. It is there. Oh, I see what I did. It was 1/5 times 100 minus b. Okay. When I first looked at that, I'm like, oh, look, it's a chain rule. It's not a chain rule. Okay. If it was me and I can distribute something when I'm trying to take a derivative, I would do that first. So dB dt equals 100 over 5. Yes, that looks crazy. Minus 1/5 b. When you're taking this derivative, you need to always do it implicitly. So I'm taking the notation would be d squared over b dt squared for my second derivative of this. So it's really the first derivative of that, the second derivative overall. Derivative of any number, 0. And then the derivative of this is negative 1/5, and implicitly dB dt. So really what I have is negative 1/5 dB dt. Now AP loves to do this to you. That's great, but we know what dB dt is equal to. It's equal to this guy right here. So I need to substitute that back in. So it's negative 1/5 times 1/5 times 100 minus b. All right, so we got negative 1/25 times 100 minus b. This is going to really have the power of it. This was a second derivative. Remember, second derivative talks about concavity. So when I have this is going to always be negative. No matter what I do with it, this number is going to come out to be negative. When I'm talking about concavity and I'm negative, I am concave down. Look at this curve now. Here, I am concave down. Here, I am concave up. So that cannot be the picture because we know the picture, it's always got to be concave down. So we need to put that in words. Okay, and you can kind of follow this work here. Therefore, 3 dots is therefore. The graph is always concave down. And a portion of the given graph is concave up like a cup. Okay. Let me talk about points real quick. Oh, I didn't do points on the first one, part of it, did I? I'll go back and do points real fast. Okay. So in the first part, you got a point for using dB dt basically. So you basically got a point for knowing that you had to plug into this thing here. And then you got a point for the answer with the reasons. You got a point for that. Down on this one, you got a point for this derivative in terms of b. So you had to keep it said in there in terms of b. That's how we knew we had to substitute in. I couldn't leave this. That's why. So you basically got a, actually it was here. Stop here. You got a point for that. And then you got a point for your explanation. So you got a point for this. All right, we're down to part C. Last one, and then we got to do Kahoot. So the kids will come back in because Andy really is excited about running your Kahoot for you. He said he gets to take over. That scares me a bit. You have to remember when we do the Kahoot, it was written by an 8-year-old. The 11, almost 12-year-old did edit it for him. So hopefully it's okay. It was better. Hopefully it's better than when I saw it. So some of them you'll be blindly guessing, and I apologize. Okay. All right. So we know we are starting with dBdt. It says in this one, use separation of variables to find the particular solution to the differential equation with the initial condition v of 0 equals 20. So everything, we're separating the variables. We've done this on 2 other problems. So 1/5 times 100 minus b. So there's my original again. I know my b's got to go to the other side, so I got to divide by that. So 1/100 minus b equals 1/5. I got to move the dt to the other side by multiplying. Okay. I lost my dB. All right, I'm going to put my integral symbol there. All right. We are going to have to use, this is what I was talking about before, and I know I don't have the right colors in here because I know what happened. I went from the online version to the desktop version, so that's when my pens are different all of a sudden. This here, I know normally I should be using orange, is a u. So u equals 100 minus b, okay? du equals negative dB. So what I am missing is this negative. If you're in BC, this is going to look a little different than what I did with you guys. So for AB, we put a negative on the outside and a negative on the inside because a negative times a negative doesn't change the problem in any way. Or it's like multiplying by negative on the top and divide. Remember how we would put, if it was a 2, we would do 2 on the top, 2 on the bottom, and put the 2 inside and the other 2 on the 1/2 on the outside. So it's acting the same way. Okay. So I'm going to go ahead and go -1/u equals 1/5 integral of dt. Okay. Because again, I should have done all my little checking and underlining, right? I now have the negative dB there, and then this is the u, and I could substitute in. All right, so I'm going to integrate. 1/u is our favorite, natural log of u. Okay, so this just got exciting. All right, and then we've got, when we integrate dt, we get d plus c sub 1. All right, I can't handle the red. All right, I'm going to go ahead and get that negative to the other side because I want to do something with it. Think about what that next step is. Everybody type into the chat really quick what you have to do to get rid of the natural log. Give me the fancy word. Oh, it's going slow into the chat. Thank you, Madison. Thank you, Nate. Good job. We all remember the awesome. Oh, Donovan's here. We all remember the fancy word exponentiate. Good job. No, not the E. Okay, exponentiate. Good job, good job, good job. Okay, before we exponentiate, this thing right here is the, remember we're going to convert that. It doesn't really matter if it's negative. I'm just, whenever we multiply by a constant, we're just going to change the name of it to c sub 2. It's still a constant. All right, I'm going to do my exponentiation. I knew just made me so proud that you all didn't forget that in the last 5 weeks or 4 weeks or whatever it's been. Okay, so these guys cancel. That was the whole point of exponentiating, and I forgot to substitute back in for my u, didn't I? Let me do that right here. I should have substituted in for my u. Let me get that fixed for you guys. All right, so my u was this 100. I got too excited about exponentiation. Okay, there we go. So this side is 100 minus b equals, and remember this thing, we got to do this weird split up thing here. So e to the 1/2, e to the -1/5 t, and e to the c sub 2. We talked a lot about that in class, and we know we're just gonna, it's kind of a memorized thing. This thing here turns into another constant. So 100 minus b equals c sub, we're up to c sub 3. Well, you could just write a c at this point if you wanted to. E to the -1/5 t. All right, I'm going to get this all the way solved for b, and then I'm going to deal with my initial condition. So negative b equals c sub 3 e to the -1/5 t minus 100. And then I'm going to move that negative to the other side. I am going to keep the negative this time in front of the c sub 3 plus 100. Because really I could do 100 minus this mess. It's kind of up to you. All right, I'm putting that initial condition in, earning more points. So 20 equals negative c sub 3e. I'm going to plug a 0 into this thing. So 0 times 1/5 is 0 plus 100. All right. Good job for screaming it, Cameron. All All right, now into the chat again, everybody. What's e to the 0 power? Make me proud. Type it into the chat. There we go, Michaela Donovan. Good job, Blanca. Zeta. Oh, Zeta's here too? Wow, we got a lot. We got everybody today. Uno, even in Spanish. Thank you. All right, so we got it 1. So 20 equals negative c sub 3 times 1. So I'm just going to write c sub 3 plus 100. I think I made, did I make a boo-boo there? Hang on. Let me look at my work real quick. No, it's got to be negative. All right, so I am going to take this and I'm going to move that 100 to the other side so I get negative 80 equals negative c sub 3. And then I'm going to move that over. So c sub 3 is equal to 80. I'm almost there. I've almost got this finished. Ellie, Andy, Mikey, come in the office. All right. And then we're going to plug into this one right here. Okay. So b, and really we should write b sub t because that's what they asked for in it. B sub t equals, the negative was from the problem, negative 80 e to the negative 1/5 t plus 100. Okay. Anybody? Adrian was in my class too, believe it or not. Many moons ago. He was there with Lauren Baum that I mentioned. This was his this was Adrian's test question probably. Okay. All right, points. Yes, points. Thank you. I got too excited about Kahoot. I'll put points on there. Okay. Oh, let me see another. Hey.
Wait, Mom, how many people are in this?
I don't know. I haven't looked lately. Ellie's looking at the chat right now. All right, let me look at the points. So points. This one is worth 5 points. That's big points. So I'll help you in a second, dude. This is 1 point right here for separating the variable. Okay. We get 1 point for the antiderivatives probably once we plug this in. So 1 point for the antiderivatives right in here. Okay. A point for the plus c. You get that point by itself this time. A point for plugging in the initial condition. So when we plugged in the initial condition here, there was a point. And then you got a point for solving for b. So this one here was the last point on that one. Okay? Yes, what's wrong?
Casey asked, how do you get the 0 on E?
How do you get the 0 on E? Okay, so Casey right here, the 0 on the E came from our initial condition right here because our t was equal to 0. The t was acting like an x in that case. All right. Any other questions on that? Either you can turn your microphone on or you can put it in the chat and Ellie is going to read it to me.
Make a bowl.
Anything coming up?
No.
Okay. Are we ready for Kahoot? Put it in the chat.
I'm gonna be.
All right. Maribel says no. Mickey says yes. Yes, yes, yes. Okay, top 5 of this Kahoot. You should all subscribe to my YouTube channel. Is your YouTube channel clean, Cameron? Can I subscribe to it? Do you have more followers than me? I've got like 102 in my YouTube channel.
All right. It's time for me to.
All right.
Mom's losing people because she keeps posting new stuff.
All right. He's got 6, so I'm beating Cameron on my YouTube channel. Awesome. Okay.
I know someone who has no followers.
All right. So here's what you need to do. Okay. Here's what you need to do. You remember you either need a second device, your phone would work, okay, or you need to split your screen. Okay. So let's look at. Let me find the Kahoot. Okay. It's right there. Okay. So we got to get logged in here. So get to that point where we get the Kahoot going, and I'm going to let Master Andy again remember the Kahoot was made.
I made the last question
by an 8-year-old. Okay. All right. So you go here. You're gonna watch, huh, Mikey?
Yeah.
Okay. So when you go into the Kahoot, make sure I know who. No. We're not doing that because I need to know who it is. Okay. All right. You want lobby music to be futuristic, or you want a disco, right?
No, 8-bit.
What do you want? What? 8-bit. Okay. Oh, that's great. Oh, that's great. Andy. Thanks. All right, here we go. Classic. Here it is. All right, get your names in there, everybody.
Ready, did you?
How many people are in the group? 31. Okay.
30. Okay.
Ready?
We're halfway there, so.
Oh, you don't want to dance?
So I like how with the dog. Doggy. Dog!
Okay, we're gonna give it about 30 seconds or like 45 seconds. If you're not in 45 seconds, we're gonna start. We got 6, 7 people who haven't been in yet. Danae is playing. You guys know who Danae is?
Oh yeah, today.
She's crashing our class today. That's okay. We love her anyway.
I see you, Connor. Miss Riley, let me join.
All right. All right, is everybody in who's going to get in? You can still get in. Somebody really quick, if you can, put the PIN number into the chat. Oh, Ellie's going to do it. Did you see it, Ellie Bells?
Yeah. 5009.
Okay, here we go. Remember again, it was written by an 8-year-old. Okay, hit the start button, dude.
Oh, let's do this.
Here it goes.
Andy versus Disney. All right. Number 1. Who's Andy's favorite princess?
Oh God.
Is it Jasmine, Belle, Moana, or Moana? I want. All right. So it was both Belle and Moana.
All right. All right, who is it? Up, Genesee is in the lead. Good job, Genesee. Okay, here we go.
Open-ended. Which character from Snow White and the Seven Dwarfs cannot talk? Okay. Taking selfies and kid. Right. 5, 4, 3, 2, 1. Hello. The
Let's see what they
answer
wrote.
was Zoe.
Winner! Winner!
Cameron, turn off the microphone. Thank you,
Give me that!
Cameron.
Who said dumpy?
Give me that!
All right,
Yeah,
next.
at least
Here we
Tay
go.
got correct.
Here we go. Okay, who's in there?
Oh,
Oh, Danae is up there. All
I love
right.
you today.
I cannot do this.
It's a puzzle.
It's a puzzle.
First, the last Disney princesses.
I have
Oh,
a in this one.
Gotta put them in order by what Apparently, Mikey plays Kahoot like Cameron.
I don't know what this is.
Would you give him a minute to do this one?
Yeah.
Okay.
Accidentally. Some people don't know my.
I'm freaking out. I don't remember.
Wonder how many people Googled it on their phone for
Sam?
minutes.
Standing strong at 21.
This Ballard. This is freaking me out. I'm panicking.
Come on, it's so easy.
Oh, you hit it. Oh, 50. No, I can draw.
Yes, sir!
I can't believe that half of us got right. For some
I'm in there.
Okay.
What's the order?
Yeah, who's got it? Yeah,
Yay!
I don't know.
I'm in
What's
there.
the order?
I'm in there.
All right. True or false?
Andy's dad has a beard.
Oh my
Come
god.
on.
How,
That's not a picture of Andy's dad.
how do we, what are we supposed to do?
I don't know, I guess.
He works at an office, so maybe not. We probably. Hey!
False. I
I'ma
like
go.
the reasoning, Cameron. That was good reasoning.
I'm going to
Yeah,
go.
he has a little bit of hair on the side, but oh, here.
All right, go
Yeah,
ahead,
yeah,
Andy.
like
Keep
we
it
do.
going. Keep it going.
Okay, all right.
All right.
When did Disneyland make its opening?
Oh shoot! It was one of my teacher's birthday.
I want this. I know it's not correct. Right, Ellie.
I don't remember.
4, 3, 2,
Yeah.
Wait a minute.
M.
Go in. Go in.
All right.
No, that wasn't right.
Keep it going. Keep it going. Ellen gave you 1955. All right. Up,
Cassandra.
Cassandra.
It's still correct.
Okay.
Come on, come on,
Yeah,
come
so-
on, come on.
All right, open-ended. What is this?
This logo? There will be a picture shown, kind of like that. See?
Oh, you have to guess it. He found things in here I haven't done before.
Images.
What the heck?
It's
Oh,
Disneyland.
what was I gonna say?
Did we have to type the whole thing?
It's the castle. Okay.
It's not long, just type it.
Second.
I'm gonna start laughing if I spelled it
I'm
wrong.
gonna cry if I didn't type in the
All
last one.
right.
Go,
Okay.
go.
Oh,
Disneyland.
we only put in one of those. You all got it right, but he only put in one answer. Sorry.
You gotta think. You gotta think in the mind of an 8-year-old. That's what you gotta do.
Right. That's right.
And you don't have to think very
Okay,
hard.
come on now. How am
I don't know.
How-
I don't know. Yeah, I'm gonna click sandwich.
Where is my
I'm not gonna try. I
answer?
feel like I should go sandwich just because you put
I
a
have
sandwich.
answers somewhere.
I know.
Bro, I swear to God, I'm gonna click
You
sandwich.
know this one, we've done it.
No.
It's not September 26th.
Hey,
It's
Ellie.
November 26th.
I was right.
Double the
Oh,
points,
This is
people.
what you get.
Double the points.
2,000.
Think in the mind of an 8-year-old. This is what
The
Andy
last
thinks
thing
about the
I
day.
think about.
How are we supposed to?
Video game. Let's say homework goes last.
I
Maddie?
swear to God.
But it's also
If
Miss
I get
Ballard's
this
kid,
right,
so maybe
I'ma
it's
start
not
laughing.
last.
You're all thinking about homework.
Miss Ballard's kid thinks about homework.
No.
They'll think about homework first, trust me.
I feel like they don't think about homework.
I know, I'm just
Okay.
kidding.
Wait, if it's homework first, I'm
I
gonna
don't
be
think
mad.
I've ever thought about a pinball machine
I
a day
forgot
in my
it's
life.
homework first, I'm gonna lose
I don't. Okay, well,
For real. If it's homework
Pinball
first,
machine it is.
it better not be first. Dinner's okay, but no homework. I put video games, pinball, dinner, then homework.
I did the same thing.
I did the same thing. I did the same thing.
I put the same thing.
Good job with your numbers. All right.
People machine. Video games.
What's the order? Homework goes
dinner
first.
last. Dinner last.
Let's keep going, dude.
You think what? Who does
This year, Toy Story is from Toy Story and Scream. What do you think?
I swear to God, if it's wrong, I must leave.
The answer.
Mikey says Lucy.
That was Lego at that too.
Oh, you do. But Mikey has that toy upstairs, don't you?
Yeah. You guys stop. No.
Next. So nobody got it wrong last time. Everybody got it right this time. Good job.
Still 22 people.
All right. Did we change? Did we change?
How did I go
Cassandra's
down?
still
How did I
in the
go
lead.
down?
Over 7.
Cassandra, I'm gonna beat you.
I'm in 2nd grade and I learned 3rd. Oh,
What is that?
I think you learned more than 3rd grade.
That picture is actually of me, so.
Aw, so cute.
You were in high school, not 3rd grade.
Please, Jesus, I'm begging you, I'm begging you, I'm begging you.
Adorable.
Only one person got it wrong.
How am I still?
Okay.
I'm like so lost.
All right.
12 people are in my family.
How many kids do you have, Miss Ballard?
That's not us.
Well, that's not
Oh
12
my
people.
god, I see the resemblance.
Is he talking about his whole family?
No, just the immediate household.
I think there's like
It can't be 12.
Panic
Can't be
for a
12.
reason.
it's not
No.
12.
There. You guys better get this one right, I swear.
Yeah.
Oh, yes! We only have
Oh my
like
god, tell
Got
me.
it wrong. Got it wrong.
it's a bundle. Order family
Oh,
from oldest
no.
to youngest.
Oh.
Kiara, you want to help out?
Oh dear
I'm
god.
not helping out one more. I have the
Oh
answers.
no.
Wait, no. My screen is loading. No.
It's so bad at
know.
what you got.
I swear to god, if I get this wrong, I'm just done with the game.
Mrs. Ballard, do you want to come in with an assist?
I know, Miss
That
Ballard.
was the one.
Help.
If I get
I can
this
do one on
wrong,
derivative.
I just don't know who's older. Like,
Or we can do one on Batman.
I might
No,
fail.
we're not doing one on that.
No, I'm just slow right
The
now.
only way I can get this wrong. Is if, please, Jesus, I'm begging you.
Oh my god. You need a
Alright,
You need.
Andy just left. All right.
Oh my god, I got it wrong.
My husband is
got it
over.
right.
All right. Here we go.
I should be here.
My screen.
Okay, 2 questions left.
What do I want to be?
That's
Oh
who you
god,
want to
I don't know.
a math teacher.
It's revealing it.
Yeah, I'm gonna put that.
This is what he wants to be when he grows up.
Cheese, SpongeBob.
Cowboy?
Oh, I see. I heard that though.
be. I bet you want to be an awesome kid.
Oh my god.
Yes.
Oh,
I need to see
there
the
was
picture.
a picture. There was a
I need to see the
bro.
picture.
Oh my god.
I need to see the picture. I need to see the picture.
Bro, Johnny's in here. What's up,
Science.
Johnny?
A scientist. A math teacher.
No, you put A scientist. I put
You guys
science.
did not admit the
Disappointed.
answer. I'm sorry, no one got it right.
Including myself.
Yeah.
All right, last one. Oh, Ellie is the best sibling. It's just a
Yes.
poll.
It is.
I prefer not to say I'm dead. That's the choice.
Oh, she said she put the last one, so she must. Yeah.
It's funny how he just put no like that.
Ellie put the last one.
I am.
Dang.
Okay,
I've been
and the winners
bamboozled.
are.
I've been bamboozled. I've been taken advantage of.
I beat
I'm
Cameron.
disgraced.
For once in my life, I beat Cameron.
I feel
And
deceptive.
Sandra's the winner.
I feel like I've been deceived.
All right.
Hey, please.
Okay, we're gonna turn the computer off. There we go.
Hey,
Okay.
just saying,
Turn
just
it go
saying,
back to this
it's not too
thing
late.
here.
It's
That's
not
not
too late
fair,
to
Ms.
follow my
Ballard.
YouTube channel.
Cam.
I'm sorry.
Just saying.
Okay.
Nah, you should follow my YouTube
And look,
channel.
but I'm not gonna cap with y'all. I'm not gonna cap with y'all. My stuff is kind of funny. It's hilarious.
Bro, I'm
I'm
so
just gonna
close
put
to
that out
300 subscribers.
Welcome,
All
guys.
right.
there. Hey,
Johnny's here again today. Awesome. All right. So, my plan is that maybe tomorrow around 3 o'clock, maybe doing another one. Okay. So if you want me to come on tomorrow at 3 o'clock, raise your hand.
For like Kahoot or like actual lesson?
From the raise, not use the little thing on the left-hand side.
I don't know how.
It's
There's a
left
button.
side, raising
left
your
top left-hand
hand.
corner.
I'm
You
on
can
my
raise your
phone.
hand.
It's not working.
Oh, okay.
Can
Put
you,
it in the
can
chat.
you let me
What does
Type
that have?
raised hand.
join the Kahoot?
Okay. All right. So I will pick. We might not do 3 questions. We might just do 1 or 2. Okay. Do you want me to do? I can do a Kahoot tomorrow, but I'm not going to do. Maybe Andy won't write it tomorrow. Okay.
Why not me?
Oh, Ellie wants to write one for tomorrow. We'll see if hers is different. Okay. All right. So here's my plan. So tomorrow we'll do 3 o'clock. Next week, what I'm thinking about doing. Okay. is I am going to start giving you, whatchamacallit, giving you enrichment points for showing up for the live session, okay?
Yes.
I'm going to probably put a poll out there, but I'm not going to start that till Monday, okay? I'm going to put a poll out there and get some ideas, because I know we do have some people who are working, okay? Because I've gotten a few, I've run into a few issues. So I'm going to probably see if I can adjust the session. It won't be the same time every day, so I give some chance to the people who have to work, okay? And it still has to fit in my schedule and my husband's schedule, okay? So what I will do on those days is I'm going to have to take roll, okay? So it's going to take me a little bit as you come in. I'm probably going to take roll a little bit as you exit. So it's going to take us a little bit of time to do that every day, okay? But if you want your points, I need to be able to do that, okay? Okay. And so here's my other plan with your grades, okay? Let's see who can get 1,000% in class. You'll never be able to do this again in your life, because all of the enrichment points are going to go in. So I'll put in everything you do, everything you turn in for videos, every time you show up for one of these, every time you do some assignments. I'll maybe put some other stuff out there to motivate you to get
1,000 points.
Get to as many points as you can. So I want to see if somebody can get into 1,000% A for class. Does that sound good?
Are the ones from this week, are they going to count towards the enrichment points?
So from being here today.
Yeah, from like this week.
I didn't really do a good job recording who was here.
Oh, okay.
Okay, so that's why I said I'm going to start it on Monday. Okay.
So for the times that you do record, like as you said, like for the people who are not able to attend them, are we still able to, like, are you still going to be able to record them and then take notes?
Yeah, I'll probably have a couple of different ways to earn enrichment points for it. Okay. But I want to see people showing up to the live ones because I enjoy seeing you. So.
Okay.
Okay.
Yeah.
All right. It makes me happy. It's a good part. Not that my children aren't a good part of my day, but it makes me happy. Okay.
Okay. So
Marissa, for the videos, I'm answering a question from the chat. The videos, are you talking about the ones from YouTube? The videos from YouTube, you have to submit it through PowerSchool, and there's a Google form out there for you to submit. Okay. And Melissa, yes, you can have to. Be honest, I'm not going to be grading any of this stuff probably tonight. Okay. So I probably won't even start looking till tomorrow morning. But I know that the like WebAssign cuts off at 5 on the due dates. Okay. I don't know. I think somebody could get to 1,000. I think that and I'll put Nate and Natalie's points back in that I didn't put in. I owe them from some AP readiness stuff that I kind of left out. So I'll put their stuff back in. So we'll see who can get to 1,000 first. All right. Natalie didn't even show today, and she wanted the Friday music. All right. Okay. I just think it's funny that I have more YouTube followers than Cameron. So, okay. Is homework getting updated today? It's due by 5 today. I might not touch it. I might not touch it till tomorrow morning. Okay. All right. Any other questions, comments, concerns? All right. Then.
Sorry.
Okay. All right. Oh, Maribel's got more people on her YouTube channel than mine. Mine's got 100 and some, 120, and I've had it for 6 years. It's sad. All right. Yeah.
I was wondering, if you are going to do time-shifted video sessions, are you going to also record those, or?
Yes.
Okay.
I'll record as much as I can, as much as I cannot use the notes or the actual problems from College Board. If we're all doing okay with that, I'll just keep doing that. So I'll record and I haven't got it up in PowerSchool, but I'll post it there. I've got the YouTube channel going. It goes there pretty quickly, quicker than I put it on PowerSchool. So yes, I will record. And I want to kind of move them all over the place, so that way people who are working get an opportunity. Okay. All right, Zeta, why don't you email me with that question? Okay. Yeah.
Even if we do still do the videos after at another time, are we still able to get a portion of those enrichment points?
I will come up with a way, and I'll do it the same way you're doing the YouTube videos from College Board. I'll probably put a Google form out there somewhere, okay?
Okay, thank you.
All right. Any other questions, comments, concerns? All right. All right. So that's it. I know we went kind of like way over an hour today. I'm sorry. I hope that the Ballards got to entertain you today. All right. All right. I will see you guys tomorrow and/or Monday. All right. I think I put the Monday time out there already, and I will try to get times kind of done. I'll put a survey out, and I'll get times done for the week, so those of you that work can kind of know. Okay. All right.
So are you doing one Saturday?
Yeah, I'll do one probably tomorrow around 3.
Okay.
We'll plan like an hour at the most. Okay. So I think that's enough at a time. All right. Okay. I'm gonna end it. Have a good week. Have a good weekend if I don't see you. All right.